Hello, StudyBuds! Welcome to the study world. I'm your StudyBud Claire, and today we're out again on a learning adventure in the world of physics. By the end of this video, you should be able to differentiate accuracy and precision in a measurement, as well as to identify and use significant figures in calculations. Going back, we have discussed how to apply the Pythagorean theorem in displacement problems. We also learned how to identify base and derived quantities and know the corresponding units and symbols, as well as how to calculate the speed and velocity of objects. Today, we are going to identify the measurements used in these problems and learn how to properly apply significant figures in calculations. To start off, let's define uncertainty. Uncertainty is a quantitative measurement of how much a defined value significantly differs from a standard or expected value. It includes a set of possible values within which the actual value of the measurement is found. We must note that no measurement is completely exact, for in every measurement, there is a corresponding uncertainty attached. If the measurements are not very precise and accurate, or if they greatly differ, then the uncertainty of values will be significantly high. Then we have accuracy. It describes how close a measurement is to the true or specific value. Precision, on the other hand, refers to the closeness of agreement between measurements that are repeated under the same conditions. One example is when you're doing archery. You straighten your arms, raise the bow where your arm is parallel to the ground, draw the string back, and then release it. You make sure that your bowstring hand targets the center or the bullseye. After several trials, you take a look at the outcome. An arrow in the center indicates high accuracy because it is on the target point. Therefore, the shot is accurate. Arrows far from the center indicate low accuracy, but since they are close together, therefore it has high precision. The shot is precise but not accurate. Arrows in the center indicate high accuracy, and since they are close together, it has high precision. Therefore, the shot is accurate and precise. And arrows far from the center indicate low accuracy, and since they are far from each other, it has low precision. Therefore, the shot is not accurate nor precise. Here's another example. You can determine and test the closeness of a set of measurements to the true value by getting the average. For example, you have a standard sample with a mass of 50 grams. When you try to measure it, you get values of 47.6, 47.7, 47.8, and 47.9. The values you got are precise, but not very accurate, for the measurements are close to each other, but the average is 47.75, which is lower than the true value. If you got the values of 48.9, 49.6, 50.4, and 51.1, the average is 49.975, which is closer to the true value. It is more accurate, but not as precise as the first measurement. An easy way to remember the difference between accuracy and precision is to remember that in accuracy, C stands for correct or close to real value, and in precise, R stands for repeating or repeatable. In measuring values, significant figures help indicate the precision of the measuring tool. Significant figures are the known digits in a number and are used to express to the required degree of accuracy. The last digit written down in a measurement is the first digit with some uncertainty. To determine the number of significant digits in a value, start with the first measured value at the left and count the number of digits through the last digit written on the right. These are the rules to remember when counting the significant figures of a given value. First, remember that all non-zero digits are significant. Second, zeros can be significant or insignificant depending on their position. Zeros are classified according to their positions. First, we have the trailing zero, which is a zero digit after a non-zero digit and with no non-zero digits to the right of it. It is significant if there is a decimal attached to it because trailing zeros to the right of the decimal are always significant, and it is insignificant if it is in a whole number. For example, 500 has only one significant figure because 500 is a whole number. But 500.500 has 6 significant figures, for there is a decimal. 1.0065 has 5 significant figures. A captive zero is always between two non-zero digits and is always significant. For example, 5001 has 4 significant figures. And leading zero is a zero before non-zero numbers, which are usually found in the decimal numbers. Leading zeros are always insignificant. For example, the number 0.001 has only one significant figure. Another, when you add the values 1.543 and 0.031, the number 1.543 contains 4 significant figures, while 0.031 contains only 2 significant figures. So, the answer must have 2 significant figures following the value of the significant figures in 0.031. Therefore, the answer 1.574 must be rounded up to 1.6 in order to follow 2 significant figures. To recap, uncertainty is a quantitative measurement which includes a set of possible values within which the actual value of the measurement is found. Accuracy describes how close a measurement is to the true or specific value. Precision refers to the closeness of agreement between measurements that are repeated under the same conditions. The C in accurate stands for correct or close to real value. The R in precise stands for repeating or repeatable. Remember the rules when counting the significant figures of a given value. First, take note that all non-zero digits are significant, the numbers 1 to 9. Second, zeros can be significant or insignificant depending on their position. That's all for today, StudyBuds. If you want to apply what you have learned so far from this video, check out the assessment material we have prepared for you on Project Cupid's Facebook page. See you on our next venture, StudyBuds!